you're due now. So without graphing, Emily, can you press the continue button for me up there? Thank you. So without graphing, it wants you to identify the vertex, axis of symmetry, if it's a maximum or minimum, and the X and Y intercept. So remember to identify your vertex. You're looking at your H and your K value. Your axis of symmetry is your X equals your H. Your maximum or minimum means, is it going like this or is it going like that? Your X-intercept, so X comma 0. And your Y-intercept, 0 comma Y. Of this graph, all of this can be done without a graph. So the vertex, looking at my H and my K, my vertex is going to be 2 comma 4. My axis of symmetry is X equals 2 because it's the X value of your vertex. This is a minimum since A is greater than 0, which means it's positive. This is a minimum. And to find your X and Y intercepts, you have to substitute the values in. So to find your X-intercepts, that means we let Y equal 0. So we have 0 equals 3 absolute value of X minus 2 plus 4. We subtract 4, so we have negative 4 equals 3 absolute value of X minus 2. And you divide 3, so you have negative 4/3 equals the absolute value of X minus 2. What does that mean if I have a negative? Is that possible? You cannot have an absolute value equal to the negative. So what that means is that you have no X-intercepts. Because it's not, you can't have an absolute value equal to a negative, so you have no X-intercepts. Okay, to find your Y-intercept, we let X equal 0. So I'm going to plug in 0 for X, so Y equals 3, absolute value of 0 minus 2 plus 4. That gives me 3 times 2 plus 4, and that gives me 10. So my Y-intercept should have been at 0 comma 10. So all of this together, I know that this is like a problem summarizing everything we've learned. So if I was to say what the transformation was, A equals 3, that's a vertical stretch. H equals 2, that means I went right 2. And K equals 4 means I went up 4. This problem embodies all of 4, we're on 2, 3, and 2, 4. Questions, comments, concerns? A lot for one problem, right? How'd you do on that one problem? Terrible, doable, all right. No comment? Okay. All right, so what we are, okay, so graphing absolute value inequalities, section 2.5. So the key concept here is that absolute values in two variables have a graph that is a region coordinated plane of the coordinated plane with a V-shaped boundary, okay? Our boundary is a V shape. Unlike linear or where it's just a line or parabolas, quadratics when it's a parabola boundary. We have a V-shaped boundary, okay? To determine which region to shade, pick a test point that is not on the boundary, okay? And you check whether the point satisfies the inequality. If it does, you shade that region, and that includes the test point. If it doesn't, then you shade the other region, okay? When possible, you should always try to use 0, 0 as your test point, unless it falls on the boundary line. So, steps to graph an absolute value inequality. 1, we solve the inequality for y. 2, graph the related equation. So we use the values a, h, and k, you know, our slope, our vertex. And then we find a test point to plug into step 1. If true, we shade the region where the test point is. If false, we shade the opposite region. So these are going to be the 3 steps that we follow. Solve the inequality for y, graph the related equation, find a test point to plug into step 1. Questions so far? Okay. So here, following step 1, we need to get y by itself. Okay. So in order to get y by itself, we're going to subtract 1. That gives us -1 is less than the absolute value of x plus 2 minus 1. We're going to divide by -1. Well, when we divide by -1, what happens to our inequality? The sign flips it. So we have y now is greater than negative absolute value of x plus 2 plus 1. My inequality flips and it changes the sign of here, divide -1. Okay, so now that's step 1. Get y by itself. Step 2 is we're going to graph this. So in order to graph this, I'm going to use what I understand is happening here. I know that my vertex is at -2, 1. And I know the slope of my line is -1. Okay, so I'm going to create my graph. I'm going to go to -2, 1. There's my vertex. When I draw my lines, I have to pay attention to if it's solid or dotted. Because it's less than, strictly less than, I have less than, that's going to be a dotted line. So my slope from here is down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, down 1, left 1, down 1, left 1, down 1, left 1, down. And because it's dotted, all I'm going to do is dash it out. So step 2, done. Questions about step 2 so far? All right. Step 3 is you choose a test point. If possible, use 0, 0. So I'm going to test 0, 0, which is right here. And I'm going to test it by plugging it into what I got from step 1. If it's a true statement, yay. If it's not a true statement, then I shade the other area. So we have 0 is greater than -0 plus 2 plus 1. 0 is greater than -2 plus 1. 0 is greater than -1. Is that a true statement? That is a true statement. So that means that where 0, 0 is where I'm going to shade. Y'all get my shading. Bam. And that will be your graphical solution. I have no clue why I wrote sideways. I got the job done. How do you feel about the 3 steps? Are we all comfortable with 1, getting y by itself? Step 2, using the slope and your vertex to graph. Step 3, choosing a test point and testing to see if it's true or false. No questions, comments, or concerns? Okay. Then we're going to try it again and then move on. Okay, so we have what is the graph of y minus 4 is greater than or equal to 2 absolute value of x minus 1. So step 1, we have to get y by itself. So in order to get y by itself, what I'm going to do here? Add the 4. So I get y is greater than or equal to 2 absolute value of x minus 1 plus 4. Okay, good with step 1? Step 2, we're going to use our vertex and our slope or our a value to find our graph. So the vertex here is 1 and 4. Perfect. And our slope equals, what's our a? 2. So up 2 over 1, right? And is our line going to be dashed or solid? So it's a solid line because it's equal to. All right, so let's create our graph. I think I'm going to go more to the right, left. So using that information, I'm going to go to 1, 4, 1, 2, 3, 4. I'm going to rise 2, run 1, rise 2, run left, and it's a solid connection. So step 2 is done. Step 3 is to choose a test point. Can I use 0, 0? Why, yes, I can. So we're going to test 0, 0 in step 1 inequality. So we have 0 is greater than or equal to 2 absolute value, 0 minus 1 plus 4. I guess because 0 is greater than or equal to 2 plus 4. So 0 is greater than or equal to 6. Is that a true or false statement? False. So I do not shade the area where the 0, 0 is. I shade the opposite space. So I'm going to shade this space where 0, 0 does not lie. And there you go. How do you feel about the 3 steps? Are they doable steps? I don't know. I need y'all's feedback. I can do it, but can you do it? Good? All right, so we're gonna move on to part 2 of our notes. Writing an inequality based on a graph. So this time we are going backwards. We have the graph, but we have to find the inequality, okay? On the last one, we had the inequality and we had to find the graph. So now we're going vice versa. So the steps, we want to identify the vertex and the slope. We want to write the equation in general form. Okay, so if we remember, general form means that we're writing it in y equals ax minus h plus k. That's our general form. We want to change the equality symbol to an inequality, inequality symbol. So you have to pay attention to whether, if you have a dashed line, then you're going to be using one of these two. If you have a solid line, then you're going to be using one of these two symbols. If it's shaded above, then you're using the greater than symbols. If it's shaded below, you're using the less than symbols. And then you're done. So again, 3 steps that we're going to follow. Use the vertex and slope, identify the vertex and the slope, write the equation in general form, and we're going to change from equality to inequality. All right. So here's our first graph. So step 1 is, what is your vertex? So what is our vertex? 3, -2. Step 2 is, what is your slope? Just 1. To get from here to here is just up 1 over 1, right? So that's our A. Okay. Step 2 is write the general form, which is what we were doing yesterday. So y equals x minus 3 minus 2. Did I have to write the 1 for A? Not really. If you wanted to, go for it, but you don't need it. Okay? Step 3 is to determine, is it dotted or dashed? It's dotted. I said dotted or dashed, it's the same thing. Is it dotted, dashed? Is it dotted, dashed, or solid? So we have dashed. So we know we're either using less than, greater than, or less than. And so then you ask yourself, is it shaded above the V or below the V? Above. So which inequality am I using? Greater than. And now all I have to do is replace my equality with the inequality. So we have y is greater than the absolute value of x minus 3 minus 2. And bam. How do we fill out these 3 steps? Still with me? Okay, so again, step 1, identify the vertex and the slope, because that's going to tell you your h, your k, and your a. Then we're going to plug it into the general equation. A is 1, so it's there, but we didn't need to write it. And then we're going to analyze the graph. Is it dashed or solid? It was dashed. Is it shaded above or below? It's shaded above. So we replace our equality with an inequality, and we're done. Cool? Ready to try the other one? So 4, what is the inequality? What inequality does this graph represent? So following our same steps. So step 1, the vertex. The vertex here is -2, 2. Okay, let's see. I think my graph is a little off. It's supposed to be here and here, but my graph got a little shifted. We'll go with it. So my slope here is m equals, should be -1. Because it's going to go down 2, right 2. So that's my A. Then I'm going to write it in general form. Y equals -1 absolute value of x plus 2 plus 2. Step 3, is it dashed or solid? Yes. Oh, it is. Thank you. You never saw anything. It's still 1, by the way. All right. So I'm dashed. So that means I'm either going to be greater than or less than. And I'm shaded above, so I am greater than. So we have y is greater than negative absolute value of x plus 4 plus 2. Good? Not good? Okay, the last part of our notes. This where it gets a little interesting. We're solving an absolute value inequality without graphing. Okay, so here are the steps that we have to follow. We're going to isolate the absolute value term on the right side. Since the absolute value cannot be negative, you will solve to determine the boundaries. So to determine the boundaries, we take whatever's inside the absolute values, and we're going to set it greater than or equal to 0 and less than 0 and solve for x. So here you're solving for x, your boundaries. And then we're going to create 2 inequalities to solve. So the symbol depends on the original. So if your original is less than or greater than, then what you're solving is going to be less than or greater than. So you're going to solve one inequality with what's inside the absolute value as itself. Then you're going to solve another inequality with what's inside the absolute value multiplied by -1. And then we combine the solutions of the 2 inequalities and use boundaries to define. And then you check to see how to go. So again, without graphing. So we have y is greater than the absolute value of x plus 2 minus 3. So step 1, we need to get the absolute value by itself. So we're going to get this guy by itself. In order to get it by itself, we're going to add 3 to both sides. So we're now working with y plus 3 is greater than the absolute value of x plus 2. How do you feel about step 1? Okay, what does step 2 tell us to do? Anybody? Nobody? It's on your paper. We're going to solve for our boundaries, right? So step 2 says we're going to solve for our boundaries. So we take the absolute value, what's inside, and we're going to set it greater than or equal to 0 and less than or equal to 0. So we're going to take, bless you, x plus 2 is greater than or equal to 0. X plus 2 is less than 0. So therefore, x is greater than or equal to -2, and x is less than -2. Okay. Step 3 is you're going to take your inequality that you have, and it's going to become 2 problems. One is going to become y plus 3 is greater than x plus 2. The other one is y plus 3 is greater than -x minus 2. So it's its opposite. So I'm multiplying each term by -1. And we solve for y. To solve for y, we're subtracting 3. So we get y is greater than x minus 1. We subtract 3. And we get y is greater than it should be 5, right? Negative x minus 5. And you're going to put it all together. So what you're looking at is the sides of your slope. Because this is the positive side of my slope, looking at your positive. So this is positive, that's my right side. So when you're thinking about the graph, you're saying that x minus 1, and it's going to be on the right side of your vertex. So it's like this over here. And this is going to be on the left side of your vertex, the negative x minus 5. So when you put it together, you're going to say y is greater than x minus 1 when I'm to the right of my vertex, which is x is greater than or equal to -2, comma, y is greater than negative x minus 5 when I'm to the left of my vertex, which is when x is less than or equal to -2. So to test it out, you just choose any points that fall into this category. So if I choose a value that is greater than or equal to -2, a value would be 0. If I plug 0 in here, does it make a true statement? Or 0, 0, any point. Nope, I go higher. You choose a point, test it, and check your answer. Okay. We're going to try one more, following the 4 steps. So again, step 1 is you need to get the absolute value by itself, this guy alone. So I'm going to add 3. So now I'm working with y plus 4 is greater than the absolute value of 2x plus 10. Step 2, I'm going to find my boundary, my point of separation. I do that by taking 2x plus 10 is greater than or equal to 0, and 2x plus 10 is less than 0. So the plan of action is to subtract 10, divide by 2. Agreed? So I'm subtracting 10, then dividing by 2. So that gives me x is greater than or equal to -5. Same plan of action, subtract 10, then divide by 2. So x is less than -5. So this represents the right side of my graph. This represents the left side of my graph. Step 3, I'm going to take the inequality and solve it. So we have y plus 4 is greater than 2x plus 10. And we're going to have y plus 4 is greater than -2x minus 10. Remember, absolute values are going to produce positive and negative solutions of each other. So I subtract 4, And I get y is greater than 2x plus 6. And this is the right side of my graph for x values greater than or equal to -5. I'm going to subtract 4. And y is greater than -2x minus 14 for the left side of my values, for x values that are less than -5. And that's what part 4 means to do, to combine.